OK，我先用中文好了。那大家午安哦，这个最后一个 round 的 fight。那我是评审团的这个主席，然后中华大学刘成邦。然后在我右手边依序由我来介绍，然后台师大的这个吴文新老师，淡江大学的这个杜昭宏老师，台湾大学的陈义玉老师，跟台湾大学的戴伟武老师。OK， 那我们今天的老师都是北台湾跟东台湾，然后跟3队大概都是南台湾的，所以就请就从 reporter 开始，然后由 captain 介绍你和你们的队伍。
So we are Typt is Kaimer from Kaohsiung Senior High School. I'm Xu Hanyu, Chen Guowei, Lin Yuyou, Hu Weizhong, fighting. Thanks.
And I'm captain of Team Excelsior, and my name is Chen Xuan, and he is Chen Taihong, she is Wu Shuangjie, he is Chen Jian, and he is Lin Kaizhe.
We are Team Rocky, and I'm captain 刘定谦、徐国兴、蔡世宇、蔡凯文、施立成。Thanks.
Okay, so I think everybody knows the rules, and we try to keep on time, so we give you some time to take a rest before the dinner. Okay, so I think the problems are already set, so then we just go ahead start it. So start from the reporter.
不是题目已经决定了吗？题目决定，所以要写那个。
Yeah, so go ahead to write down your name. As a reporter, you have 5 minutes to prepare. Okay, so reporter, please take the stage. Oh, sorry. Still 1 minute. Yes, please.
Okay, so honorable judges and fellow competitors, this is reporter from Team Caliber. Today I want to report problem 60, cushion catapults. The current statement presents that when we place an object on a larger cushion, it drops several items in such a way that the first object is catapulted away. So our task is to investigate how the exit velocity depends on the relevant parameters. Here is the variable I have done in my experiment. So our main focus will be on the mechanism behind this process. So how the air pressure and the membrane affect this phenomena and how the energy is transferred during this physics process. So here's a simple observation about the phenomena. You can see that the black coin here can be away. So here's a brief outline of my presentation. First, so how the phenomena actually happen. So when the orange ball crushed on the cushion, I think it will push the gas molecules away like this. So at this moment, the volume of the cushion will decrease, causing an instant increase in the air pressure. So an increased air pressure will make the air push the red ball with a strong force like this. So it makes it catapult away. Oh, so how we now know what happened during this process. So while the product statement focused on a large air cushion, and I think it is because when the cushion is too small like this, the orange ball may interfere with the red ball like this. So I think the reason to use a large air cushion is to make this ball separated to make sure that phenomenon will happen. Now, and here's my theory part. I use the box modulus tape to describe how the cushion value changes under impact pressure. And we can compare this formula with the Hooke's law. So when the x increases, there will be a force in the opposite direction, same as the cushion, like this. When we press the cushion, there will be an opposite pressure difference against our force. So according to the paper, we can get the air bug modulus right here, so I will use this in my following theory. Here, let's talk about the theory about the cushion. So when the ball falling down on the cushion, the impact pressure difference can be calculated with this formula. And then we consider the air pressure bug modulus. So we can calculate the change of the volume by using this formula. So finally, combining this equation, we can finally get the pressure after the cushion is hit by the ball. That's called the pressure P prime. And then the P prime will put the force on the red ball right here. And using the Newton's second law, we can finally know the exit velocity equation right here. Next, there's a problem in our theory. So how do we know the contact area? So in the contact mechanism, the radius of the contact area can be using this equation to know the contact area. So after introducing our theory, let's talk about the transformation of energy. According to work energy principle, the kinetic energy of the red ball will be equal to the potential energy minus some energy losses. So based on this mechanism, we can define the energy conversion efficiency. E is this formula. So after introducing our theory, here's our experiment part. First, I will use a box model to simulate this phenomenon. Next, I will change the parameters about the object And finally, I will see how the cushion properties will affect this phenomenon. So first, let me explain what is a box model. Because when the ball falls on a real cushion, like this, the volume around the cushion will expand. So the reason we use a box model is to confine the expansion only in vertical direction to simplify this phenomenon. For the setup, I use the air pump to control the air amount and use PF5 to measure the pressure inside the box. In first experiment, I want to test whether this box will actually affect the exit velocity because so this is a membrane on the box and it's only a membrane. And here's our experiment data. We can find that when there's only a membrane, the exit velocity didn't change much. However, if we add a box under the membrane, that the exit velocity would decrease. In next experiment, we want to test the number of the ball, whether it will change the exit velocity. So here's the data. We found that when more ball is dropped, there will be a higher exit velocity. However, there will also be a higher energy losses. And I think it is reasonable because in our formula, that if we drop more heavier ball and the contact area is larger, there will be a higher exit velocity. And we found that the best efficiency occurs when we drop one single ball. Therefore, I would use one single ball to do our following experiments. Next, we use a real cushion to do the experiment. I use a stick board to fix the initial height and mark on the cushion to make sure the position is same. Next, we import the slow motion videos into the tracker. Therefore, we can track the exit velocity and the contact time. So, in the first experiment about the cushion, we want to find the relationship between the drop height and the exit velocity. Moreover, when I do this experiment, I also use a Blender simulation to simulate the movement of the ball. Here's how we do the simulation. We use Python to export the data to Excel. Therefore, we can find the Excel to calculate the exit velocity. And here's our experimental data. From the chart, you can see that the trend is the same. When we drop the ball from a higher position, the exit velocity will be larger. And then, this is the simulation line. We can tell that the simulation line is very close to our experiment. And then, here's the important finding is that when height beyond the critical value, that there will be a stable energy conversion efficiency, which is roughly 70%. And I think the reason of the stable energy conversion efficiency is because of the ball impulse. Next, I want to compare the falling ball mass. Here's our experimental video. You can see that when we drop heavier ball, the ball will exit higher. So here is our experimental result. We can find that when the falling ball mass is heavier, there will be a higher exit velocity and higher efficiency. And I also think it is reasonable because the heavier ball is, there will be a higher initial energy. Next, we want to find the relationship between the cushion pressure and the cushion volume. So here's the experiment. We keep adding the air into the cushion and see how the bumps and the pressure will be. So initially, when we add air into the cushion, the volume and the molecules will increase. So the pressure will remain at the same point. However, if the bumps beyond the critical value like this, and we continue to add air into the cushion, the pressure will increase. So I define the critical value is the filling rate like 100%. Next, in our experiment, I want to compare about the filling rate is 40% and the filling rate is 60%. From the experiment data, we can find that when the filling rate is 60%, there will be a larger exit velocity and a larger energy efficiency. So this result makes me think about how does the filling rate really affect this phenomenon. So I keep conducting the experiments. So from the experiment data, from the experimental videos, you can see that the 55% just jump higher than the other two. Here's our experimental graph. You can see that when the filling rate is 61.5%, there will be a maximum active velocity right here. However, what if the filling rate is larger than 100%? So we can keep conducting the experiments. You can see that when the filling rate is 130%, the object had the highest. Here's our complete experiment data. We can find that after beyond the filling rate is 100%, when the filling rate increases, the exit velocity and the pressure also increase. In conclusion, let's go back to the problem statement. So when we have to investigate how the exit velocity depends on the relevant parameters. So I do list various variables. First, we compare the membrane with the box and without the box. You can see that where there's only membrane, the exit velocity remains the same. However, if we place a box on the membrane, the exit velocity will increase. And then we find that when more voltage dropped, there will be a higher exit velocity and higher energy efficiency. And then we can find that when the drop height increases, there will be also a larger exit velocity, and if the drop height beyond the critical value, there will be a stable efficiency. And also we can find that when the falling ball mass is increased, there will be a higher exit velocity and higher efficiency. Finally, this is how the filling rate affects the exit velocity. So when the filling rate is between the 0% to 100%, the pressure will remain at the same value. When the filling rate is 61.5%, there will be a maximum exit velocity right here. And if the filling rate beyond the 100%, the exit velocity will increase while the pressure increases. And I think the physics meaning behind this graph is very interesting. So I think it will be related to the ball impulse and the air amount in the cushion, and also just how the filling rate will be like. So I think we can discuss the physics meaning behind this graph later with the opponent. Thank you.
Thank you. Okay, so opponent, you have 2 minutes for questions.
Okay, can you explain why the arrow bar in your chart is so big?
I think it is normal because even though we try to control the initial height and the cushion, there might be some errors because our machine is not that accurate. But we do the experiment multiple times, that can increase the accuracy.
Okay, so do you think will the object mount up in another vertical direction will affect this data is not so accurate?
Oh, you mean? I think no, because I don't just analyze the vertical exit velocity. I analyze the vertical and the horizontal exit velocity. And so I don't think that will affect our data. I combine these two directions.
Okay. Can you the experimental data is not very matched to the theoretical line. Can you explain why?
Okay, so in our theory, we didn't consider about the energy losses, and also energy losses might caused by some friction, and also the cushion will absorb some certain amount of energy. Therefore, I think it is normal that our experiment data is lower than the theory one.
Okay. And will the ripple first object may influence the second object? Like first object fall down and you make a ripple and inflect the second object.
Oh, you mean there's a wave on the membrane?
Yeah.
Oh, I think the wave on the membrane also affect this phenomenon, and I think it is a good point to discuss.
Okay.
Okay, thank you. So opponent, you have 3 minutes to prepare. Okay, opponent, please take the floor.
Okay, our topic is cushion capital, and we are the opponent from block routing. And the power statement is place an object on a large cushion and jump the zero object in such a way that first object has to away and investigate how its velocity depends on the roller parameter.
Stop the clock. Stop the clock. Okay. Please make sure the connection. We stop the clock.
Press the button, the power of the projector. 但是它现在节能，我们要再按一下。Okay, try again.
So just a reminder, do make sure the connection is good before the next stage.
较
他电脑公开你也找不到时候，电脑公开你也不行。换一台电脑也是好。
外地那时候用，我都设定了，好，
计时的，其实电脑是放到中间，中间突然这样，先这样，我去找东西。
计时怎么办？计时就是，还是我就拿这边前面的，
就是至少大家可以看得到时间的话，就稍微让大家可以看一下。Okay, so now everybody can see the clock, right? Okay. Maybe So can you put a little bit backward?
Actually, we didn't see the clear tone,
You see the area.
Okay, that's okay.
Okay, so 1 minute is your penalty. Okay, so go ahead.
So the main focus on energy information and pressure. Report summary is the theory is energy transformation, and experiment is whether the box is put on under the membranes or not, and changing the number of ball and finding the relationship between the drop height and the exit velocity, and changing the mass of the ball, how the filling rate affect. And result is the higher drop height is, the more exit velocity it will be, and result is the heavier the mass of the ball is, the higher exit velocity and efficiency it will have. And the higher the drop height is, the more exit velocity it will have. The higher filling down rate is, the faster the increased velocity you will have. And for reported policies planning the experiment clearly and multiple experiment about the topic and clearly explanation and using multiple independent variables to conduct the experiment and consists known. Okay, let's come to our question. Okay, let's continue the question we have done before. Do you think the ripple, what will the ripple affect the object?
I think just in a minute. Like this, just when the orange ball causes a ripple, so we will make the volume decrease and just get about the way.
So how to ensure the about the way is the air pressure to cause this or the ripple the back?
I think just the wavelength will be is a good point to discuss, but I think just our focus should be on the research in our report.
Okay. And if they change the shape of the object, what effect will show?
I think shape of the object will affect the contact area in the mass, maybe the mass. So yes, I think it was a fact, but I think just we can talk about some search about my report.
Okay.
For example.
And turn to page 2. The chart is like wave at page.
Chart like a wavelength. You mean?
Oh yeah, this. What causes the data is go up and go down?
Okay. So I think we can divide this chart into 3 parts. Like, so I will explain why when the filling rate is lower than 61%, that's the exit velocity will increase. So we can consider about air cushion. So like when the filling rate is very low, like 20%, that when we drop a ball, like this. Like when we place the object on it, so when the filling rate is like very low, 20%. So when the object hit by it, the surface will not be the tightest. However, if the height reaches a critical height, that's when they drop on it, the surface bounces will be the tightest. Therefore, there will be a max exit velocity. Someone?
Yeah. So I want to ask if the pressure is lower, do you experience this?
Oh, okay. So first I will just define the filling rate again. That the filling rate is divided by defined as the number of months divided by the critical value of months. And here's the critical value. So first, if we add air into the cushion, that initially the cushion is deflated, and we add pressure into the cushion, that the volume and the molecules will also increase. So the pressure will remain at the same value. However, if the bumps that's beyond the critical value, because the cushion has a maximum volume, right? That's if the cushion is reached the maximum value, that we continue to add pressure into the cushion, that the pressure in the cushion will increase. Yeah.
Okay, I want to ask, the energy of the object slowing down will then transform to the cushion entirely. So how could you calculate or measure this energy loss?
Also, we can calculate the energy loss from this, because I have this calculated efficiency about the object. So we can use the formula to calculate the efficiency. Here's the efficiency. Like we can see that when we drop heavier ball, there will be a larger energy efficiency.
And how could you ensure the object is hit on the same point? Because if the shape of the cushion is not very It's not same as the last time. So how did you
Okay.
ensure?
So because throughout my experiments, I have used the tape like right here to control the position and use the initial dropper to drop the ball. So I think I didn't change anything in my setup. So I think the position will be the same. It's zero.
Will your cushion move or not?
Well, I have used tape to just under the cushion and tape it on the floor. Yes.
Okay.
So the cushion will move a lot.
I want to ask if the two object position distance is the same, and
Yes.
if other object fall down in a different position, will it affect this?
Yes, I think if the distance change, that will definitely affect the exit velocity. So in my experiment, I just control the position of the ball so that I can control the distance between the two balls.
Okay. And have you considered that when the ball hits, the volume pressure go up, and what is the effect?
Okay, so here I want to talk about the physics process about this graph again. Okay. So why there's a maximum exit velocity in 61%, and I think that it is related to whether the surface of the membrane is tightest. So as I mentioned before, and very low when the filling rate is very low, like when we push on it, the surface will not be tightest. However, we keep adding air into the cushion. That's at some critical point that the surface will be the tightest. Okay, so when we drop the ball like this, the surface will be tightest. Next, the ball will kind of be higher. However, if we keep just add air into the cushion, that's the original. That here is the launch ball and here is the falling ball position. So if we keep add air into the cushion, this here also be tightest. So when the ball fall on it, the energy will come back to itself. Okay, I can use the experiment video to explain. From this chart, you can see that when the filling rate is 85%, that the initial falling ball will also bounce off. That means the energy come back to itself. So therefore, the energy here is be lower than the 55%. Okay, because the 55% the ball didn't bounce off. That means the energy is completely transferred to here.
Do you think why the velocity is highest in the 61%?
I think just in this case is 61%, but that means every condition that the fast filling rate will be 61%. Just in this case.
Okay. And
yeah.
Okay. Will the filling rate is go upper and will it higher than 61%? Because after 100% is.
Oh, you mean if we keep increasing the filling rate, that will the exit velocity will beyond this point?
Yeah.
Oh, I think it might be big. The reason we don't just keep adding the filling rate percent is because we're afraid of that the cushion will explode. Yeah. Okay. And here I want to explain why when the filling rate is beyond 100%, that the exit velocity it will increase. So I think it is because when the filling rate is beyond 100%, that the surface will be like this. You can see that the surface is very tight. Therefore, we can think of this is like a string bed floor. So here's the surface, and here's the object. Here is the larger pressure. The filling rate is larger than 100%. When we drop the ball like this, the surface will be like this. So the original object will kind of run away. So if we increase the pressure under here, that the force upward will be larger. Therefore, if we increase the filling rate, that the pressure will the exit velocity will be larger.
Okay. And the last question: do you think the different materials of cushion will lead to different outcomes, like the 61% will become like 71%. Or
Yes, I think the elastic modulus of the cushion will affect the best filling rate. But I control the material of the cushion in my experiment.
okay, thank you.
Okay, so opponent 1 minute summary.
Okay, summary. We mentioned about some other factors like the shape of the balls that may affect the experiment, but the reporter points that we should focus on his experiment. And the position that the ball dropped in the cushion will be the same while the maximum height is at the filling rate of 61%. And the higher the maximum height is, the higher exit velocity it will have. And I asked if the rate is so higher and is more than 100%, will the velocity go
Okay,
higher?
time's up. Thank you. Okay, so now is the new clock set already? Okay, you can start your computer. So please reset the clock there and we. Okay, so now, reviewer, please take the floor. 3 minutes.
Okay, so the first question for both of you is, what will the potential energy of the releasing objects turns to?
Okay, since the initial potential energy will convert to the kinetic energy of the object, but also the cushion will absorb some energy, so there might be some energy loss.
Okay,
Okay,
and did you consider some boundary limits of an experiment, just like whether it can allow the object to bounce off or not?
Oh, you mean there might be the critical height is low enough that the object just, I think, yeah, yes, I think there will be a critical height that if the height is very low, but so the object will just don't even move.
Okay, thank you. And the opponent?
I think if you drop it to water, I think you will get lower. Yeah, good.
Okay, and since your cushion isn't flat, so will the object you put on the cushion just scroll down to the boundary of the cushion?
You mean the object on the cushion will go down?
Yeah.
Because there's a, oh, so therefore I use a black cone, because the black cone has the, wait a minute. Just like here, because the surface is so tight and round that it is impossible for us to place a ball, right? So I use the black cone surface.
Okay, thank you. And what do you think that in what position did you place the object on your cushion? Will the height of the bouncing height be the highest?
Oh, I think the position will affect the maximum height, because I think there might be some wave on the membrane.
So what position? Like?
I didn't, just because I control the same position in my experiment, but I think if the object is placed on like the wavelength, up here there's a wave, and up here that maybe the maximum height will be the
Okay,
height.
thank you. And the opponent?
I think it's maybe the peak of the height, peak of the wave, so the object will become
Okay,
higher.
thank you. And will the elastic force of the cushion acting on the catapulted object, like?
Yes, just I say that if the film rate is like larger than 100%, we can basically.
Okay, time's up. So reviewer, you have two minutes. There. Okay, go ahead.
Juries and fellow competitors, I'm the reviewer from Team Excelsior, and today I'm going to review number 16, cushion catapult. And this is a problem statement. Place an object on a large air cushion and drop several other objects in such a way that the first object is catapulted away. Investigate how the exit velocity depends on relevant parameters. So we will mainly focus on what does the first object catapulted away and the relevant parameters that will affect the exit velocity. And this is a review for the report. He shows the here observation video that's the both of it in her phenomenon. And for the theory report, he used the book module scale, contact area, and the pressure difference. And there's also 5 points in her experiment, including the membrane, drop height, different material of the object, and the filling rate. And these are the pros and cons of the reporter. He considered the unstableness of the setup and tries to reduce the error cost. That he had a structure that can release the ball. And also he showed clear video, and he had done a lot of parameters, which I think is quite good. But however, he still lacked of some parameters that I think is quite important, just like the material and the geometry of the objects. And also, he didn't analyze the catapulted angle. And this is a review for opposition. He noticed that the discussion of catapulted angle, which I think is quite important in this phenomenon. And also, he pointed out that the reporter didn't explain about the errors. However, he didn't consider the placement of the object, that I think is also an important factor in this phenomenon. And he spent too little time on the experiment part and also setup part. And for the first key discussion, the opponent asked how will the shape of the object affect, and the reporter said that it will affect the contact area with the cushion. And I think I agree with the reporter, since the contact area and the force acting on the object is proportional. And the next one is about the energy loss. A reporter said they calculate. And I also think that the energy transferred to the cushion has some loss. And this is our question. I asked that in what position will the object all answered about the peak of the wave, and I agree with both of them. And the next one is the energy transfer. I asked that what will the potential energy of the object turn into? And I agree with the reporter that the cushion and the energy loss will all absorb some energy, so it won't all turn to a kinetic energy. And this is a point missed in the discussion. They didn't discuss about the deformation of the cushion. I think it's quite important. And they also didn't talk about the reporter's stability of their setups and the arrangement of the cushion. And for the parameters, they didn't discuss about the material of cushion, which I think if the rigid one and the elastic one will have different impact, and also the shape and the object. And for data analysis part, they didn't.
Stop. Thank you. So, reporter, please conclude.
So here's the concluding remark from Think Sabre program. So the theory I have with the bulk modules, temperature difference, Newton's second law, and contact mechanism and transformation of energy to explain this phenomenon. And in experiments, I have used box model with the membrane and without the box. And also, I have to discuss about the amount of bulk, drop height, and the mass of the bulk, also the filling rate about the experiment. Next, here's our conclusion. When there's only membrane, the exit velocity didn't change. However, if the box under the membrane to confine the gas, then the exit velocity will increase. And when we jump over, there will be more exit velocity and more efficiency. And we drop from a higher position, the exit velocity increase. And also, the mass, if the mass of the falling ball increase, the exit velocity also increase. Also, if the filling rate will have the maximum at 16.1%. So, about this discussion part, we discussed about the error bar and some setup about my experiment setup. So, but I think I just use a single approach to fix the initial height. Yes, I think I can just drop the ball kind of stable. And then for experiment part, I just discussed about the membrane wave and also explain the physics process about my experiment graph. And also we discussed about the distance. However, in my experiment, I didn't change the distance. And also, we discussed about the filling rate being lower than 100% and higher than 100%. And we discussed about the position of the object. Yes. So I think I can control the position of the object in my experiment.
Okay, thank you very much. All right, so now it's time for a question from the juror.
The problem says you drop several objects in a way to get this maximum height. So it was a little discussion about how you arrange this location of these several drop objects.
Oh.
And it seems there are some obvious conditions to get maximum height by arranging these all objects.
I think you mean the. Oh, I get the point because can we use it? I think just the position because I think when the ball fall on the middle, like middle of the cushion, that's the middle of the membrane is softer. The edge will be more stiff. That's if we drop the ball just only on the very soft part, that the gas will be easy to transfer to another part. The deformation will be increased. Yes.
Reviewer and opponent.
Okay, then I will answer that. I think that it's if we persist the ball on the wave, like the releasing ball falls on it, and the peak of the wave that is produced by the releasing ball, then the object will have the highest bouncing height?
And I think if the vertical object is bounce to the cushion, then if all the peak is to one point, the point is highest.
So can I ask a question from the reporter? So when you compare the results with or without the box, are the two surfaces made of the same material?
Yeah, yes, they are same material.
Okay.
The material is PVC.
So you actually put the film on
Yes,
the
and they are the
box,
same.
not a cap.
Yeah.
Just the-
They are the same material and same area.
Okay.
At one point of explaining why there is a peak in your curve, I seem to remember that you said something about the contact area being kind of optimal for this particular point. But did you actually make any measurement of the contact area regarding this point?
Yes, just because from the equation we have to know the elastic modulus of the membrane and the ball. So I have just considered the contact area, but I think the theory value of the contact area is so optimal. So, but
Okay,
I didn't have the data on my presentation because it is not.
I see. So you believe that this theoretical explanation probably should be correct.
Yes.
Okay.
Further question from the viewers? No? Okay, so now it's about scoring time. Please take a seat. Okay. All right. So the score for the reporter is 8. 9. 8. Score for the opponent 6. 5. 6. Score for the reviewer 8. 7. So I think the score are pretty consistent. Any juror want to make additional comment? No? Okay, so let's leave the technical theaters behind and take a good rest and be prepared for the stage 2.
陈炫拿笔出来，快点。
白同学，眼睛白，我眼睛白，好像只有你这个大概有听懂我要的问题。这个问题在这个好 problem， 你不要再问这个问题了，我为什么都没谈的？丢2个球、3个球都丢同一个地方。这个很阿妙，就是说我的 question 是 spinning around，然后我说一般 在这个时代，
他甚至已经告诉你了。
这会是会基本上好像就是会，然后下基本上他那个其他的领域的人就被类似像是一个水波，你看是有方水，然后你可以带着这边多碰一下，风一定在中间的，这边多碰一下。这个所以为什么都没有碰这个问题？这他们不是写的。知道他是他其实第一啊，
对啊，我有点想到，
我觉得你们去试看看吧，那个他让你这个东西看到，这个有趣的，我觉得这个是在韩国电影，我不太相信这个是会是一个 universal 的现象。是的，这个有一个课，可以到100分。我感觉像大概试看看，找一个比较像一个圆形的店，然后上面比较平整一点，然后摆在中间 drop 在一些前面往里看看，然后怎么样？其实最主要是说不选的界面啊，在什么时他一旦跳出去了，后面就没什么关系了，就跟这题跟这个乒乓球的题有什么关系？对不对？就一题乒乓球，那就是弹出去了之后，后面这个出去或者水球变就没关系。我的直觉是说这个 drop 是东西是在那个 symmetric 的位置最好。当然就是它就是要高三。不，他说我的计划都是我一个人知道。因为我后面才进来跟大家就是聊聊天。没有，我是借用你的例子，所以1年高三。好，没事，谢谢。我觉得我们必须，因为他其实还有活动线啊。对啊，这种大概用一个好一点。我刚才跟你也用个塑胶袋出来冲，他很累，好像会讲比较。对，昨天很累的时候，再好的也没有办法算好。对，他开始，我们就是多讲更困难，但是
医生，
文化一点的话，
卢正良，
啊，
在小高这
不然的话，就反正物理都难有最难的。
背错了。
对啊。对啊，反正物理就是很难的东西，物理学家就是要查问题出话嘛。对，没有错。这可能要到大学了。高中对，应该是吃晚点。我直接的有这个太多了。
哦，这样子啊。这样大。因为你以前还是但有这样哦，就要秀但是你这样根本就没办法跟其他人讨论。
我觉得比较好的就是说，先看这个 statement 是什么，然后就是说，在这个话为什么出发，因为我觉得什么问题最关键等等。一的是像你刚才讲的，我白手打 radio， 我们连这个评审都这样子，傻眼了，对不对？对啊。
哇，真的。
他们就
太强了一点。
自修大二，所以现在反正酷我们应该是找了花儿的 AI 的这么厉害。 反正出台下去，搞不好就一大堆东西。
是哈，对，哎，我还没想到，这样越来越难。
现在的学生报告真的就是需要那个，
真的是蛮贴路的。
现场讲的时候，
因为你要真的实验，你有做得到，你还可以讲得出来懂一点。
但是我看这个 GPT， 你就是把这个 premium service， 你真的把一个文章就对着给他，他那个写的 report 真的是，
但是那也不能随便用。那边看它其实有些东西英文好像记得很漂亮，但其实你没有，不一定要。
对，它是我觉得我用的感觉就是一些你 miss 到或你不知道的东西，它提到，对你会知道说，哎，这个东西你可以去查一下，但是你再多问一点，他就讲不出来。
对，它就是几千万。
对，但是你要问到很仔细的，他
后面第二章在第二段就是你自己顶多是英文搜出来。
那个学生的报告的话，看起来就会漂亮亮。其实我觉得这个就是教学生怎么用这个还是有好处的，所以我觉得这有点像是叫 delicate 的，就是说要怎么样，完全不让他们用的话，好像也不太对。对啊。
可以改进啊。
我知道，我完全懂你。你礼拜三早上跟我讲的那一种，完全体谅到，真的是。所以要达到的。它是有30分钟可以睡，对，黄金都带化学，建议本哇，是啊，其实你吃的速度挺快的，20分钟。
真的不用
我刚看过
快半了就讲一下后。
水也快没了，可以的话就收回。
这边可以。
去年就是他那个代表国际剧团。
他们直接接旁边来。这边都用苏梅卖吗？没有，
我没有输给他。
那个你们先有些
时间的切过来了。
等一下，他在用。没有想到的就这写到谁去就好了。
有了。啊，你们那个就自己切掉。
那等下时间到再把它切掉。
电影那靠不要。
按上下左右就好。
我先不要，我先不要，好好听，你好好讲，英文是下，非常好。
他们刚好。
人家教的就是你看前面的测试机，自动决定的设置。人家是学长带学生。我觉得这个比较危险。我们可能第一届因为你是双语嘛，然后另外就科技班的选手。
Computer is okay.
Computer. Okay, hello.
Okay.
Okay.
So if everybody agree, we can just proceed. Okay. To take up the time because at stake. All right. So we wait for the brightness of this screen, and then we get started. Okay, this is stage 2, and we are going to discuss problem 5, and then recorder, you have 5 minutes for preparation. And please write down your representative. Okay, please.
Okay. Honorable journalists and dear fellows, I'm a reporter from Typt Property, and today my topic is problem 5, ping pong rockets. So then comes to problem statement. A ping pong ball is placed in a container of water. When the container is dropped, the ping pong ball will get launched to a great height. What maximum height can you reach with up to 2 liters of water? So we think we should focus on the relationship between water volume and height because they mentioned 2 liters of water. Okay, and we observe the phenomenon. Drop a cup filled with water, and water inside will rust upwards. But if we put a ping pong ball in it, the ball will rise a great height greater than the water. So this is our hypothesis. The reason why ping pong ball rises is due to the momentum transfer from water. So the more water there is, the higher the ball should rise. So this is our simple theorem. Before it hit the ground, because this time the gravitational force doesn't work, so the surface tension takes the place. So you can see the water is on the wall. And when it hit the ground, the water surface first be the flat, and then the ball will rise up, and some water will fall. So we think there are two main reasons that there are 2 reasons that affect the height: surface tension and momentum transformation. But within the surface tension is hard to calculate, so we concentrate on momentum transformation. So then comes to the first experiment to understand the relationship between water volume and maximum height. So we change the volume of water, and we count the sample, count the ground, some material, and the maximum height should be changed. But releasing by hand can lead to some error. So we make an experimental setup. This setup is into the board and the box. So so as you can see, when we are doing experiments, we will put the cup on the edge of the board. So when we releasing the cup, we make the cup to fall as vertically as possible to the ground, and this is a video in our experiment. As you can see, we put it on the edge and it falls, and the ball rise up. Okay, so that comes to our experiment setup. We use 4 cup beaker, experiment setup, chat, and item. So first we use a beaker to measure the volume of water and put it in the cup. So put the cup on the experimental setup and use Funk's level to make sure the ball is level, and release the ball to every ball height, and release it in 0.68 meters height. And we use record as our data. So let's come to our first reason. The maximum height of ping pong ball is related positively to the volume of water. When the water volume exceeds 250 milliliters, the ball will hit the roof of the building, and its flight height is higher than 3.5 meters. So, but we don't know the accurate height. And it's our chart. As you can see, the station is positively related. But we think what impact of container materials will do. So we do the second experiment. We change the container materials and control the sample, ground, and some control variables. So we do the second experiment. And as you can see, we use steel basin as another material of containers. So the step is mostly same with the previous experiments to measure water, but we put a lot of water up to 2 liters in the steel basin. and the same water volume in a plastic cup. So we do an experiment and change container and repeat it again. So in the second result, we observe that steel basin shows lower heights compared to the past one, or we can see it rise very low, and in the video you can see. You can see the ball just rise a little. We repeat this experiment about 3 to 4 times, and it shows the same result. So we speculate that it's because steel does not change shape easily compared to the past one. When it changes its shape, it may put the water off so the ball rises. But if it's the water in the ball and make it rise, due to the conservation of momentum, the mass of water that hit the ball should directly influence its initial velocity and influence its height. So we change the bottom area of the container and make it what depth is set, so it has different water volume. And if the result is reach the same height, we can say it is dependent mainly on the water depth. So we do a third experiment. So we need to use 2 different cups, but the cup's material should be the same. So we put the water into 1 cup and put it in the ping pong ball, and the depth is we measure is 19 centimeters, and just release the cup and record the height. But the different cups, one has 1 liter of water and another has 2 liters. So we think the mass is enough to make it stable to hit the ball. So we didn't use our experiment setup, so we used hand to release it. And after do the experiments, we add water to another cup and same that as previous cup everything. So we come to the third result. If the water volume is different, the maximum height is almost the same. So it can be determined that the height is mainly affected by the water depth rather than the water volume. And maybe there are some other factors that affect height, such as surface tension. So you can see the big. So as you can see, I guess on the so the ball is almost there, but it is okay. So you can see the height of it is almost the same, just have such a little difference, but we can see the tendency of it. Okay, and that comes to the discussion. If there is water on the ground, it needs to be removed to avoid absorption of impact. The water may absorb some momentum, and we need to control the ball in the center of the cup to avoid colliding with the cup wall, and maybe the heat of water, the center should have the maximum height. Okay. And as the ping pong ball bounce at different heights, because sometimes the bounce in the cup ball or the cup fell vertically, not vertically like this. So it may change its height. And the problem statement takes 2 liters of water. So theoretically, if the water volume is 2 liters, the water depth can reach up 159 centimeters. Because there are 2 liters of water, and the radius of our ball is 2 centimeters, and so it's a bottom area. But the maximum height should be very high, as you can see. Only 19 centimeters it can reach up 4 to 5 meters. So change of air density will affect the maximum height significantly, make it hard to predict. So that comes to our conclusion. From our study, the ball does rise due to the momentum transfer of the water, because more water increases the maximum height significantly. Steel materials show higher heights compared to the plastic one, because steel is not easy to deform. What mainly affects the maximum height is the depth of water rather than the volume of water, because the ball will only hit by the water directly below it. The maximum height we obtained when the water volume was 2 liters in plastic cup was 4.4 meters, such as the video we have watched. And water depth is 22 centimeters. But this height can be increased further if the bottom area of the container is reduced. So that is our outlook for our future prospects. The result would be more accurate if the device can be controlled with a remote control like this, and the device can be ensured to be a sand level. The initial velocity of the ball can be measured to determine the momentum transferred from the water to the ball using tracker. And the height of the cup releasing can be adjusted to observe the impact to the maximum height of the ball. We concentrate in momentum transfer, so we don't do this. And this is our reference. Thanks for listening.
Thank you. Okay, so now, question from the opponent.
And thanks for your report. Then I want to ask you some questions. And for the first question, is the rebound velocity of the container bigger than the velocity of the water jets?
Oh, you say when before it hit the ground, is velocity of the
No, I mean if the container hit the ground, then it will rebound back, it will rebound up. And is the rebound up, the velocity of the rebound up, the bigger than the water jets, the water jet velocity? Which one was bigger? Water jets. It will form the water jet, right?
Yes.
And which one was bigger?
And
Okay, thank you.
And so we think the water's velocity is higher than the container.
Okay, thank you. And is the ball's immersion depth in the water constant while the free ball? The motion of the free ball.
Motion.
When you release the container and the ball, this motion is called the free ball, and is the immersion depth for the ball be the same in the whole process?
Due to the air resistance, there may be some difference, but you think it is small, so we think.
Okay, thank you. And do you think that the shape of the container will affect the maximum height?
We don't do this experiment, but back to the theory.
Okay.
On our theory, we think just so if we change the shape of container, the force it should be same. So we think it doesn't matter.
Okay, thank you.
Okay, so opponent, you have 3 minutes to prepare. please start.
And honorable juries and fellow competitors, I'm the opponent from Team Excelsior, and today I'm going to oppose problem number 5, ping pong rackets. And here's the problem statement. A ping pong ball is placed in a container of the water. When the container is dropped, the ping pong ball will get launched to a great height. What maximum height can you reach with a 2 liters of water? So our main focus will be how do different parameters affect the launch height and the mechanism of the phenomenon. And also what maximum height can the ping pong ball reach. And this is the report's outline. First, in the theory part, the report mentioned the surface tension, which is the main reason of the phenomenon. And then the report mentioned the momentum transformation, which is quite clearly. And for the experiment and data analysis, the measurement for the report is the maximum height. And for the parameters he has done is the water volume, the container material, including the plastic one and the steel one, and also the bottom area of the container. And for the error analysis and controversy, which the opponent thinks that maybe the unstable setup will have some deviation causes. And here are the strong and weak points. For the strong points, the report has shown clear illustration of the experimental setup and the method. So he has well demonstrated the releasing method and clearly demonstrated. And then he also has a good observation video in which demonstrates the phenomenon. And also some critical parameters are tested, just like the water volume or the area of the bottom. However, for the weak points, the report didn't consider the wave in the water, and he didn't clearly explain the effect of the container's shape, and he didn't have any experiments about the container's shape. And he has lack of the quantitative discussion on the theory, so he has no theory line, so he couldn't compare the data with the quantitative theory. And here are the points that I will later discuss, and which can be divided into 4 aspects. And for the first one is the launching analysis. I would like to discuss how the coefficient of restitution change in the whole phenomenon, and which I will mainly focus on the container, characteristic of the container, and the ground. And then I will discuss about the Washington jet, how it's formed in the phenomenon, and how it may affect the maximum heights. And then I will discuss how the forces acting on the system, which will be the buoyancy and the viscosity of the water. And then is the falling analysis. We'll discuss if the ball will sink into the water and how will it sink, and what will affect it to sink. And also the opponent thinks that the air resistance will affect the phenomenon well, so that we'll discuss it later. And for the parameters, we'll discuss how the container change will affect the maximum height, in which I will discuss the diameter of the container and the material of the container, and also the shape of the container. And also, during the whole process, vortex or swell may form on the water, and I'll discuss how it will affect the maximum height, and also the surface tension and the hydrophysics. And then it's the experiments. For the measuring parts, we'll discuss the parallax and the releasing method, the stability of his experimental setup. And for the last part is the data analysis. We'll discuss how the air resistance and the deviation caused by the releasing angle and the measurements, which will be the capillary sinking. And that's all. Thank you.
Okay, you can discuss now.
And then I use the blackboard to discuss.
Yeah.
Thank you. And can you draw me the 2 image that shows us how the motion of the ping pong ball and the forces acting on the system. And if this is the free fall, the motion of the free fall, and this is after the collision. This is after it rebounds to the ground, and this is the free fall motion. And if this is the ball, this is the forces acting on the system. This here is the water surface and how the forces act on.
So what's the computation analysis?
And so how will the gravitational forces acting on this here? What will play the role then?
It just make a force.
So you mean that when the container is dropping, it will have a gravitational forces? And will it have a surface tension acting on it?
Yes, surface tension, but we think it naturally has with this. And
So what is the direction of the surface tension?
direct of surface tension, you think acting on the ball or something?
Acting on the ball.
Here, acting on the ball, we think when it is rise, the surface tension works. So it doesn't take when it's ball, it doesn't take surface tension.
You didn't take surface tension into account when it is dropping?
Yes.
So you think that only the gravitational forces were acting on the system when it is at the free ball motion?
Yes, maybe area resistance.
Oh, okay. However, the opponent disagrees with you. The opponent thinks that the gravitational forces and the buoyancy forces, and the gravitational forces will not exist. Maybe you can say invalid here. The surface tension will do the work in this direction. So I think here the surface tension will act like this, which is different from the thing we just said. And then I want to ask and here's the water level, and the container drops to the ground, and it will rebound, right? And for the collision, the motion of the collision, what will they still analyze how the force is acting on it?
So the ground plane and ground more force.
And what about I want to discuss the whole system about the ball and the water.
Because the confidence we will make the same one. So the water will give for a force and the surface tension.
What does the force?
What is the
What force is the force?
The water
Hits the ground and it will have force that. And what? So it will equal to this or it what?
No, it may the form momentum we can if I may take into say the whole momentum is it and before it hit the ground it has velocity v and the whole momentum is
Okay, I only want to discuss the forces. And how about the gravitational forces? So, well, the other forces acting on the system?
Other forces
The buoyancy forces? Like this?
Yes.
I want to agree with you. It will have, when it is at the motion of the collision, it will have the gravitational forces, right? And also the buoyancy forces. Okay, thank you. And I would like to also discuss about since you have mentioned in your previous quantitative theory model, you said that the water jet will form, right? And how do the water jets form? I want to discuss and the dropping for it. What is the step that the water jets form? Yes, water jets like this. I mean the water jets like this. Since that the ball will bounce up is because that layer will form. This is the water, and they will form water jets, so that the ball will bounce up due to the water jets. And how does it form?
How does it work? So from this to this.
Yes. What is the motion here? Is it dropping or? And can you draw me the ground of the ground?
So when it ejects the ground, so the cup will be it, so it will deform. So
What do you mean? Can you say it again?
Such as it may not always take the ground back. So
difference, the container won't horizontally put the brown, touch the brown. So
we introduce, but
how do you release your container?
we use our external setup. So
Use your hand or use some
our external setup. Yes, that. So it is a board and the board will but we use level speed to make the board and put the cup on there. So we reducing. We make and we do our glue ways to make sure it can blend and we can heat temperature.
What do you think how will the container drop like this way and how will it affect the maximum height? It will bounce higher or bounce lower?
I think the force first on this, so we make the form as like this. So
what's this?
what is different? It is like deformed.
Is this the wire?
It is
Okay.
Then this the cup. So
where's the wire jets?
so the water deposed and
Oh, okay. So it will form the wire jet. Oh, okay. So your point is good. And so you had mentioned that the rebounding velocity, well, which one will be bigger? You said that this is the wire jet, and which one will be bigger? Can you explain why? V1 or V2? V1 is the wire jet, and for V2 is the rebounding velocity for the container. Which one will be bigger? And can you explain why?
mass of run is the mass of run is much bigger than this. So we can see the transfer as it will fully map this.
Oh.
So
And the
so if it has the beat, right? Yes. So the whole of it there is
okay.
equals to first it will
and the opponent thinks that there is another explanation for this, which is because the continuity of liquid. The continuity of liquid tells us that A1 means the cross sectional area, the area of the area of here. Yeah, about the area. And will equal the V2, and this is the block and A2. And so A2 means here. The ball, right?
So the ball displays the water.
Yeah. So this is the A2. So A2 is small, right?
Yes.
Small, and so that A1 is bigger than A2. Big, so that the B1 will be small. Then this one will be big, so that B2 will be bigger than B1.
So you can use
which is all because of the.
Okay, time's up. Thank you. Okay, opponent, please summarize.
And here are the discussion summary. And first, that we have discussed how the water jets formed, and then how the forces acting on the system, including the motion of the free fall, and also the collision. So that during the free fall of the water container and the ball, the gravitational force and the buoyancy force are invalid. So we only need to consider the surface tension acting on the system. And when the container hits the ground, which means the motion of the collision, water will gather at the position of the ball and forms a water jet, so that the water will rebound it up. And then since that the continuity of the liquid tells us that the velocity 1 multiple the area 1 will equals the velocity 2 multiple the area 2, so that the rebounding velocity was smaller than the water jet velocity. And thank you.
Thank you. So now, reviewer, your question time.
Right. So for the opponent, so in your points discussed, right? You mentioned working condition.
Yes.
So I'm very curious about how do you think about the working the jet and how could it be applied to these phenomena?
I think when the container hits the ground, right, and then it will have maybe a shaking from the side of the container, and it will make a wave that it will have a wave, and it will have concentrate to the maybe you can say the middle of the container. So that does the wave concentrate to the middle of the container, and that's the water will. It will have the water jet, so that the water will.
So do you consider that a Worthington jet needs to have an air cavity to?
Yes, we have an air. If the ping pong ball hits here, it will have you can say a vacancy or capacity here.
So does the opponent agree that this needs to use a Worthington jet to discuss? Yeah, correct. So, all right. So for the opponent, so in your discuss, you mentioned that in a free fall motion that there would be gravitational force. There would be gravitational. Oh, all right. So
I disagree with the reporter. I think that the buoyancy force and also the gravitational force are invalid during the process of the free fall. Only the surface tension will be considered.
Right. So, and you also asked about the shape of the container.
Yes.
What do you think would affect?
I think if the shape is a circle, and since that it will have a shock wave will concentrate it, the efficiency will be the most great. So that it will.
So what would it change to, like rectangular or triangle?
Oh, you mean that?
Yeah. What would it change?
I think first, if the ball doesn't place the position of the ball isn't at the middle or on other position, the maximum height will become smaller, and so that I think that the maybe the shape of the container will affect how the maximum height.
Right. So for the opponent, for the reporter, I want to ask. You mentioned that it would hit the roof if it's too high, right? So what if the roof doesn't exist? So would the height continuously grow?
Yes,
what do you think about that?
Can you explain your question?
So they mentioned that the ping pong ball hit the roof, right? What if the roof doesn't exist and will the height of the rebound go like higher?
If there's no blocking on top, and sure the ball will become higher.
So there's no boundary limit.
There will be boundary limit since there has it has the forces, the gravitational forces for the ball, so it will drop, right?
Okay, thank you. Our reviewer has 2 minutes to prepare. Okay, reviewer, please go ahead.
So alright, I'm the reviewer from Typt Excalibur, and my name is Brian Hu. So today I'm going to review problem number 5. So when the beam bubble is placed in a container of water, what maximum height can you reach up to 2 liters of water? So the theory the reporter used they uses surface tension and momentum transfer to explain the theory. And the experiment part, they change the different water volume and the container material and also the depth of the water. And the setup, they use board as a dropper, and they use tracker to measure data. But some of the experiment they use hand to drop it. So I think they can add more experimental setup for this. And the result, the main mechanism is the momentum, and the main factor is the water depth. And when the water depth will affect more than water volume, will affect more than water mass volume. So also when the water volume is up to 2 liters, the water depth can reach up to 159 centimeters because of their water bottle, and the maximum height is very high, and also the air density will affect. And also, so for the straight up reporters, I think they use some simple physics explanation and qualitative understanding about the phenomena and the detailed data about the radiation height. And also, they lack a clear explanation for the experiment result and lack of comparison between the theory and the experiment on the chart. And they didn't control the contact angle between the container and the flow, which is a very important thing to control. And so about the summary of the opponent, so they use this they talk about force analysis and talk about free fall and when it hit the ground, what would be different, and they ask about surface tension, and the experiment part, they talk about the mechanism of receiving fall. And also the strengths, they point out some crucial factors such as water weight and restitution coefficient, and discuss about the Worthington jet. And so a suggestion, they didn't clarify the conclusions in the report, and they're a little bit confused about the Worthington jet effect, and I'll explain it later. So the opponent asks, can you draw the image shows how the force acts in the situation? And the reporter considered the force caused by the gravity and buoyancy and surface tension, but the opponent disagreed. And the opponent asked how did the jet form, and the reporter said that the drawing forces from the ground. But after the discuss, they believe that it's bounced off from the edge of the container. And so I asked about, do you think that Worthington jet needs to be considered, or why? And so the opponent asked about the shaking from outside of the container will finally cause a Worthington jet. And I asked about the air cavity also. But in the experiment video, we cannot clearly see the air cavity from the video. So we believe that they cannot use Worthington jet to explain about this. And I also asked about, did you think about the gravitational force while free fall? And the reporter said that yes, it will, but the opponent disagreed with the reporter, and I agree with the opponent that when it's free falling, the gravitational wouldn't work. And so how does the shape of the container would affect? So the opponent answers where there is a round bottom area, there will be the maximum height, and I agree with the opponent very much because I also think that this is the concentration of the water jet that would cause the jet will be higher, and when it's used by the rectangular or triangle bottom, maybe the concentration will not be that good. And I asked about the reporter that what happened if the root doesn't exist. And the reporter said that it would be higher, and the opponent agree with it. But I think that there will be a boundary limit that if there is too much water, the energy cannot be that concentrated, so that the water will not bounce that high.
Thank you. Okay, so important. You have 2 minutes to conclude.
Okay, so with our remarks and in the discussion time, we discussed over the process of launching the ball, including how the surface tension works as well as multiple force that include in the phenomenon like buoyancy force or suggest force we have mentioned. Moreover, we discussed our problem about the stability of the experiments, and we discussed the responding velocity and water velocity and the moment that the container hit the ground. So, and both the area or both the area and ball and the container will influence the maximum height. And this is our report that maybe we can change the shape of the container and observe that it will be in that situation, such as the opponent and reviewers mentioned. And we should consider more force and calculate such as buoyancy force surface tension. And do more experiments about changing the container material, such as we can make the glass if it doesn't break. Okay, and that's all. Thanks.
Thank you. All right. So now, jury question time.
So you all three groups seem to suggest this formation of this water jet is important because they push up this ping-pong ball. So if someone argues that this water jet formation is much later before this ping-pong ball actually leaves the surface, the water surface, then how do you refute this objection?
So someone say water jet is before or after?
Formed much after this ping-pong ball actually leaves the surface.
Oh, so someone say the water jet is after the ping-pong ball release. So I think this after the same time, as we can see in our video. So the water jet is followed with the ping-pong ball. So we think it is after in the same time.
It's not slow motion moving. It's not slow motion moving. I cannot see that.
Slow motion. Yes.
Alright, so I think so it's like a simple like phenomena. So when you push the ping pong ball down into the water, the buoyancy would affect, right? So maybe when they contact the ground, the buoyancy will affect first, and then the water jet will push up the ball after.
And I think that after the container hits the ground, and the wire will gradually from the side of the container and concentrate to the middle, and then thus it would let they will form a jet to let the ball rebound up.
That's your belief. That's not mine. So okay.
First. Okay, thank you. I just wonder, and because someone, the report said the material or the container will influence on your result. I just wonder if you put a certain amount of water, put in a different same material container, what will happen?
First, I think that it will affect the stability of our experiments. After the container gradually drop to the ground, the stability will be affected, and also maybe the shock wave formed from the side of the container will be affected, so that the efficiency of the concentrate will be affected. Thus, the maximum height will be affected.
And I think about if we change the material of the container, the deformation of it will also be affected. So the wave peak also there. So maybe it will affect the maximum height.
I mean the same material container. If the container made from the same material.
Same material.
Yeah, but with different size, different radius.
Different radius. Yeah. Because our result shows that the water depth influence. So we think if the radius is smaller, it will by height.
So I think with the bigger radius, but the same so with the same height, right? Water height, right? So
same amount of water.
Same amount of water. So maybe the different radius of the bowl, but the same amount of water, it may change the water height. So maybe it would affect it by the water height. But if it's the same water height, if the radius gets bigger, I think it would get maybe decrease because of the energy loss that it creates.
For the opponent, yeah, you suggest that the water jet is the main effect, right?
Yes.
Big into the push of the ball, right? So then you can prove whether it's not, right? So if you can control the water jet, right?
You mean control the
water jet? I don't know.
The motion of the water jet, or what?
Yeah, the water jet may for different liquid or for for different amount of water, whatever, yeah. Then you can see how the effect because of the water jet, right?
Yes.
Yeah. Have you done that? But have you think about that?
I had to think about maybe changing the density of the liquid or the attributes of the liquid, or also maybe the volume of the water. Which parameter will change the washing jet? And I have considered it before.
So you still conclude that the water jet is the main cause.
And the ball will rebound it up. I think it's mainly primarily because of the jets, the water jets.
Yeah, okay.
Yeah.
Maybe
you want to answer?
Yeah. Maybe different parameters will affect the formation of the jet, but I think it's still the jet that mainly pushes the ball. Yeah. That's my answer.
But you still disagree with that, right? Do you? You didn't talk about that before, right? In your presentation.
I didn't put it in my presentation. Okay. Yeah. Unfortunately, we only have 5 minutes. We have coffee time. All right. So it's the scoring time. Okay, so the score for the reporter is 7.766.6. And the score for the opponent is 9.877.6. And the score for the reviewer is 8.777. Okay. So any viewer want to comment? No. All right. So okay. So let's take a break.
好，等一下。那个。
我要出去吗？
你要哪里？我知道，我知道。
球都已经离开了狮子后的世界。
跟如果完全是真的是最重要的，最容易做实验的，改变那个就变科技了。这个才是我知道的结果。
所以讲，那个可以
那不是高的 energy transfer 这种感觉。
开的这个慢动作电影在这个界面，我就直接是求到就后跑，就挖的键才开始提升。
都没问题。改变到是多少？我去拿。
把我们再送回5实验室，大家可以有点套方法。
那你要用我们做的题目，给他打那个服务的实验室里面。
买要分析买。对。
装一下。
地上，但是我们找委任做这个，我有写。
所以看这个 free fall 是怎样？那个 free fall 是怎样？被打好的球，这是那是谁写的？这是谁写的？为什么写 free fall？ 免费的球。免费的球片。你刚才对，是这样一个球片吗？应该是两个球片。加油，你超级强！你要不要？再把那个。看你有没有对手。看你有没有对手。
我因为你们，所以我每次都有暗示。他现在是没有文件卡，还是去快点。你说对，你很他骑摩托车，对啊，像这边的话，全部给我们是音乐人加别人的鞋，把那个鞋子上面就受不了，所以我要开比较远，对，没错，因为他会决定加有一个最好那个字，很难过，对，就一定是把它。其实对，它是有点像是。对，我们现在就是在先做预习。对。
那就没有，因为我是。
像这里唯一的好处就是说女儿可以直接超过。没错，对。昨天他们两个就你来家，他们就出去逛街了，两个母女逛得很高兴啊。其实就是啊，对啊，其实真的对，很快的，然后就想要吃什么，想要弄什么就买，不然自己的比较一般老人家就用很多也是，什么都一般要手这样，我觉得大概对。这边我们是在六线
我还在。
对啊，前几天居然跟我聊，
我生气了。
对。 没有，我就跟他讲说，我岳母那个脚是不太能够走啊，就是说计程车到台北来的话，他就尽量就在这附近试过，他就坐。可是一回原因呢，
这个是我们老师的，这个是你的老师，对，那这是我们老师的，好，谢谢。
所以就是说，陈宇，就是如果是你乱，你一定也是用走路的啦，你不会用计程车。对对对，他就那么对啊，那个老师我就觉得那么好的老师，就跟他这老师很像。是啊，对。是啊，对啊。对嘛？然后学校里头给你奖学金，什么都好了，生活都没问题，老爸也不用出钱的，关那这个我们毕竟因为一个是太一个是靠别人，对对，这样就叫他是对他们
那个吗？
哦，没有在，都没有在那个。试一下就可以开始。
遇过一次，但是我们目前为止真的，不一样。对呀，今天就从今天第一个不一，第一个我们接触到。
Okay, so let's save some time and start. So, okay, this is the last stage of this round. Okay, we are going to discuss about problem 10. So, reporter? Reporter? Oh, reporter, you have 5 minutes and to write down your name. According to the rule, okay, the results answer 3 times. You have to change something. You have to reduce for 3 times. So you cannot be a review 3 times. You have to change somebody else.
再给3个人的话，差不多。
Okay, please go ahead.
Honorable juries and fellow competitors, I'm the reporter from Team Excel here, and today I'm going to report number 10, magnetic gear. Here's the problem statement. Take several identical fidget spinners and attach neodymium magnets to the ends. If you place them side by side on the pin and rotate one of them, the remaining one starts to rotate only due to the magnetic field. Investigate and explain the phenomenon. So main focus will be how do gears interact with one another, what is the comfort ratio of the gear, and what special motions do your gear exist. And here's the outline. I will talk about the phenomenon, theoretical model, experiments, discussion to the conclusion. The phenomenon. And this is my experimental setup. I make the spinners by 3D printed so that it can be parameterized, which means that the characteristic of the spinner can reach my expectation. Also, it will be easier for us to increase the variety of our experiments. And we use the 3D printed to make the spinners so that it will have a uniform density, so it will be easier to simplify the calculation of moment of inertia. And one of the spinner is connected with the motor, so that the motor will maintain a constant velocity on the spinner. And this is called the driving side. And for the other side, other spinners that does not connect it with the motor will be called the passive side. And we have used the lifting table so that we can control the spinners will reach the same height. And this is the observation video. As you can see that when the driving one starts to rotate, the passive one will rotate only due to the magnetic field. And we also found out that every 2 driving teeth will push 1 passive teeth to spin. And we also observed under different circumstances, and we found out that every 2 driving teeth will push 1 passive teeth to spin, and every 3 driving teeth will push 1 passive tooth to spin. And so here we have defined the spinning ratio, and with the spinning ratio will be an turn ratio. And then I'll talk about the qualitative explanation, which is about the energy transfer. And when a teeth gets enclosed, and it will obey the law of the conservation of mechanical energy, which means that the kinetic energy of the driving side will decrease and then transfer into the potential energy. So the potential energy of the magnets will increase. And at the same time, it will have a repel force, so the repel force between the magnets will increase. And then so that the passive one will rotate due to the repel force. And then the magnetic potential energy will decrease and then transfer into the kinetic energy of the passive one. And since there are no other torque or forces acting on the system, so it will obey the law of the conservation of angular momentum. However, the kinetic energy won't transfer successfully in every condition. In specific positions, there is no significant transfer of kinetic and potential energy. And here we have defined a comfort rate as this. And then I'll talk about 2 boundary conditions for heat transfer conditions. And for the video above, you can see that the passive one will rotate synchronously with the driving one. So the convert rate is 100%, and this is what we call a successful transfer. However, for the video below, you can see that the passive one doesn't rotate at all, so the convert ratio is 0, and it is a failed transfer. And then it's a theoretical model, and here's the coordinate of our theory. And the angle interval between the teeth will be 2 pi divided by the number of teeth. And then with this, we can know the position of the magnetic dipole. And thus, we can know the distance between the magnetic dipole through this equation. And then we will calculate the equation of motion through the Lagrange equation. And here, the kinetic energy will equal the I multiple omega squared, and the magnetic potential energy will be like this. And here we consider we have the perfect magnetic dipoles, and we obtain the dipole moment mu by measuring the field through the Gauss meter. And so that Lagrangian will equal the kinetic energy minus the potential energy, so that we can have a calculation for the equation of motion. And also we need to consider the viscous damping, maybe from the airflow, air resistance, and the friction between the bearing and the spinner. So that we first let the spinner rotate, and it will gradually decelerate. Then we fit its exponential damping, and then we can know its beta. And finally, after the calculation of the equation of the motion and the numerical solution, we can use the Python to simulate it. And we have simulated the complete successful transfer and also the failed transfer. And here's the theory about the convert ratio. When gears react reach stable conditions, it means that the phenomenon repeatedly occurs. So at the driving side, it will maintain a constant angular velocity, and for the passive side, it will decelerate due to the damping. So it needs the driving side to push it to accelerate. And in other words, it needs the passive side must be pushed by the driving side to maintain the spinning. And here's the stable convert rate, and which will be like this. And here's an example about how the convert ratio we calculated, so that you can see that this is driving side and this is passive side. The convert ratio will be like this. An experiment. At first I obtained the effective distance, and we found that when the dipole moment increases, the magnets intensify. The magnets interaction intensifies, which means that the magnets will interact each other and more significant. And also effective coupling distance will increases, and which can divide it into 2 parts. And for the first part, within the effective coupling distance, the phenomenon remains because the driving keeps pushing the passive, which is the green side. And for the other one, which is the outside of the effective coupling distance, is the red side. For here, passive continuously dissipated kinetic energy till it stops. And here is the multiple gears. And both the qualitative and the theory model can be used in the multiple gears, just by one to match its theory. And the direction of the spinners will be like counterclockwise, clockwise, and counterclockwise. And so this is the chart that shows the omega changing over time. And here's the theory line, and here is the experiments. And the damping will cause the angular velocity to decrease, and the passive side will push it and result in acceleration. And here's the convert rate for the experiments. And for the fixed parameter, the number of t for the driving one is 5, and the number of t for the passive one is 3. And here's the prediction for the theory. As you can see, at certain angular velocity, there do exist different spinning ratios. And however, which means that there could exist different angular velocity for the passive one. However, in our experiments, we only observe a certain range for the spinning ratio. And here's our explanation. For the upper boundary, the passive experiments significant damp if it goes too fast. And for the upper boundary, our explanation is that the spinning too slow, so it will fall into failed transfer position. And so that the spinning ratio tends to situate it between 1 over 1 to 4 over 1. And this is from our experiments. And then we can calculate its convert ratio will between 40% to 160%. And Moreover, we have to do different kinds of parameters. However, we found that the moment of inertia, length t, dipole moment mu won't affect the comfort ratio. Only the spinning ratio will affect the comfort ratio. And that is the discussion. First, I will talk about the chaoticity. And I can divide it into 3 phases. And for the phase 1, the velocity coupling. Through magnets, angular velocity transfer between gears. So it will take in turns to increase, decrease, increase, decrease. And for phase 2, reversal motion. Specific position exerts strong repulsive force, so the magnet gears will reverse direction, so that the direction of the angular velocity will be different, will be reversed. And for the last phase, chaotic oscillation. So angular velocity shows the obvious chaotic irregular oscillates. And this is the last phase. And then is the end about the energy. For the kinetic energy, we will have the angular velocity, which we will calculate by this. And for the magnetic, the energy will be used the angle. And when the kinetic energy experiences exponential decay due to the viscous damping. And so here is the exponential decay. And the magnetic potential energy peak, kinetic E, will transfer into potential E, and the velocity will decrease it. So it will possibly spin reversely. And last, for the conclusion, why does the gears interact with one another? We observe that when the gears are approaching, since there is a repel force, so that the passive one will spin. And we also believe that the repel force will enable the kinetic energy of the driving side transfer into the passive side, and also the potential energy. And we define that the spinning ratio is an integral ratio related to the angular velocity related between the gears. And what is the comfort ratio of the gear? For the quantitative explanation, is that the passive needs to be pushed by the driving one to remain spinning. And for the quantitative, comfort ratio will be equal like this. And for the experiments, the valid comfort ratio will be about this range. And also, the moment of inertia, length of t, dipole moments won't affect the comfort ratio. And so, what special motions do the gear exist? If we add more gears, which means that we have several gears, the neighborhood gears spin in the reverse direction, so that they do exist oscillation of angular velocity. And second, removes fixed speed model. The magnetic potential energy peak will transfer into the so that the angular velocity will take turns to increase and decrease. So you can see that in this video, it will accelerate and accelerate, 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 so you can see it in motion. And thank you.
Thank you. So, opponent, 2 minutes for questions.
Okay, so did you always control the position of the magnet? Just because I see like in your video, just like this a magnet, you always put the magnet on the gear or beside the gear.
Oh, the position that we replace the magnets will be the same in every experience.
Oh, okay. Let's discuss later. So if you turn the first one is clockwise, so do you consider that the second one will be clockwise or counterclockwise?
Counterclockwise.
Yeah, I got
their
it.
direction will be
So,
different.
What's your mu0 means?
What do you mean?
In the page 16. What's your meaning to the mu?
We have obtained the dipole moment mu by measuring the field through the Gauss meter, and this line is the 59, and this point is that from our experiment to measure the dipole moment mu.
Okay, I got it. So could you turn to the page 25? So when you consider that why the t will be the positive and over about 10 seconds it will be the positive.
Oh, it will gradually decay due to the damping, and which is because maybe the air resistance and also the maybe the friction between the spinner and the bear.
Okay, so in your previous calculation, you consider that is angular momentum with conservation, right?
Yes.
Do you also consider that the momentum will also conservation?
What do you mean?
The momentum.
I agree that the angular momentum will conservation of the angular momentum.
Okay, so you consider that is an attraction or repulsion of the magnet causing it to rotate.
The repel force causes it to rotate.
So it's the
since there the dipole.
Okay, let's discuss later. Could you turn to the page 19? So could you explain about your, the integer ratio?
The integer ratio is.
Okay, time's up. Okay. So opponent have 3 minutes for preparation. Okay, opponent, please take the stage.
Okay, so I'm the opponent today from Typt Caliber. So this is the current statement of the magnetic gear. So they take several identical fidget spinner and attract the neodymium magnet to their ends. If you place them side by side on a plane and rotate one of them, and the graph has to investigate in this phenomenon. So for a summary of report, the report used a force analysis and they measure the magnetic field and also measure the torque and use energy transform, but I didn't consider that. I consider there will be some problem I will discuss later. And they also use the angular kinetic energy. And they also talk about the magnetic potential energy. And for spin, they also talk about the rotational ratio, the position of the spinner, and they use about 2 to 3 gears, and the damping of their data. But I consider that there will be some problem because the report didn't explain more about the oscillation. For setup, there's a spinner to control the angular velocity of the first gear. And they use ePython to simulation the gear. And for parameter, they can the convert rate, which is about like this. And for a number of the gears, they only use 2 and 3. But the first statement say that it could be several. So I would consider that it should be do more about the number of gears. And the passive at the driving side. So I consider the first gear, which they use the printers, the spinner to control, is the driving side, and another is the passive side. And let's also talk about coupling distance and angular velocity. And for strength of the reporter, I consider they have done the qualitative phenomena explanation and have great setup because they can control angular velocity of the first one. And they have good analysis on the angular velocity and they try to measure that. And they also use a magnetic potential to explain. And then do different variables, just like the several gears or maybe the distance of the suggestion. They can explain more about the magnetic field that change in the phenomena. They didn't explain the interaction of several spinors. So because the energy loss, I consider that there will be different energy loss between the 2 or 3 gears. And explain more about the gear's characteristic. So they should provide us specific data about energy transfer rates. And for discussion, I want to know that the position of the magnetic on the gear. Because like I asked at the short question, because like they only put the small magnet on the top of the gear. But I consider that they may try to use put the magnet on the side. So the method they to measure. I want to know how to measure the magnetic field. So because I consider it's keeping rotating. So the magnetic field will keep changing. I don't know where they measure the magnetic field and how. So while the tracker track the middle of the gear. Yes. And for data analysis, I want to know how to explain the trend of the experience graph, like maybe the oscillation. And they have to clarify the tip of the gear for data and the placement of the small magnet. So that will take more.
Please.
So first, we just turn to a problem statement page. So because the problem statement say that they take several, but you only take 2 and 3. Do you consider that you can do more the spinners?
And since I have mentioned that our theory model and all the theory model can be used for several spinners, we have proved it from our report. And so I think that we can use 2 spinners and to know how will they maybe several spinners and how will the phenomenon be like.
So how about the energy loss? You consider the energy loss will be the same with the 2 or 3 or more?
I think we should take 2 spinners and view it as a system and only view 2 of them.
So could you show me the page that you calculate the energy loss?
And here is the exponential damping that will fit, and the exponential damping, which is due to the maybe you said energy loss, maybe it's from the friction between the bearing and also the spinner, and also the air resistance we have considered in our viscous damping, which we found the exponential damping line would be like this.
So in your experiment, in your equation, I didn't know that where is the exponential like. So do you derive the equation of the exponential, or you just fit the data?
For this, we first said that the spinners rotate, and since we didn't have connected the motor to this, so that it will gradually decelerate, right? And
yes.
Through this, we'll know that we can fit the exponential damping. If there's no energy loss or the friction between the bearing, I think it will rotate continuously. But if it accelerates, it means that it will have damping, so we can fix the exponential damping.
So you consider the damping just because that it decreased because you didn't add a more angular velocity to the spinner, right?
No, because the air resistance. We consider the air resistance will gradually that the spinners gradually stop.
Okay, so
and also the friction.
So about the air resistance, could you explain more about air resistance? How you know that it affects the spinner? Because I didn't see the equation about air resistance.
For viscous damping, that is for the explanation for the viscous damping. We think that the air resistance and the friction will cause the viscous damping, but so the viscous damping for the damping line we think that it is majorly dependent on the resistance of the air.
Okay, I got it. So could you turn to your problem statement page again? So because the problem statement says that they have to identical fidget spinner, but like I said, you use a 3 and a 5T. So you still consider that it would compare to the,
here is the I think I have go to the dictionary for the Cambridge dictionary and go to search the meaning of the diametral. It is not exactly the same. It can be very similar. And for what is the similar one? We have the same material. They have uniform density. And then they have the same structure, which is because they are made by the
but just for a shape, we can just look at it. I consider that they are not very similar because it's a 3 tip or a 5 tip. Do you consider that it would conflict with the
we have not only the teeth that is only two teeth or 3 teeth. We have so I have previously I have the spinning ratio. It is 1 by 1, and then so we have maybe 3 teeth to 3 teeth. So we have not only the different amount of teeth, but also the different amount of teeth.
Okay, so could you explain more about the tip one to the tip page? You mentioned that a different tip effect.
You mean the amount of teeth? How
yes.
it affects?
Yes.
Okay. And here's the comfort rates. We have this is the angle velocity of the driving one. This is the angle velocity of the pen.
So for the 1.1, I consider that is very similar to the identical, but it has a more error bar. So do you consider that there will be some problem?
For the spinning ratio, it could not only be it doesn't represent the amount of the teeth are the same. For the spinning ratio, we define it as if two teeth will push 1 teeth, and the spinning ratio will be 2.
Okay,
2
so
over 1.
About the push, could you explain more about is it attraction or the repulsion? Is it not the repel force?
Since we have placed the magnets,
yes.
The end pole is upward, and the other side for the spinner, the end pole is upward. So it will have a repel force with it. So it will gradually repel. So it will rotate.
Okay, so could you turn to a page like you measure the magnetic field?
And here's for the measurement of the magnetic moments.
Yes, so could you tell me like where you measure the field because I cannot keep rotating.
If this is we measure the in this point at this point.
So it's above the small magnet.
And here's this is the magnet.
Yes.
And we measure this point.
Yes.
And this is the N pole and this is the S pole. We measure this point.
Yes. Okay, so I want to talk about the fixing process. Could I use the blackboard?
Sure.
Thanks. Just because that is here, and you say that you put the magnet on the gear, right? Because maybe it's like the end. So because another gear, it will still be end. So so I didn't know that because that is the side of the small magnet. So I didn't know that what's N or S. I mean, the repulsion or the attraction.
Here at this side.
Yes.
Okay, here at this side. And so here is the N pole, and here is the S pole.
Yes.
And this is maybe the driving one. And for this one is the passive one.
Yes.
Yes. So this in turn will have a repel force.
Yes, but they will still this attraction force, right?
No, yeah.
Yes.
It will have an attraction force, right? So we have considered it for the theory, for simulation, and also the Python can use it.
So I want to ask about how if you change the direction of the magnet to like this side, like the N and S.
I think if this one will also change this side.
Yes.
I think the phenomenon will occur the most significant when if this is the spinner, right?
Yes.
This is the spinner 2. And the phenomenon will occur the most significant at this side since that the repel force will at this moment will be more significant, right?
Yes.
And however, if we rotate maybe like this way, for the theory part, we need to consider more about since it will be more the important things that it will be more harder to calculate the.
So because as it rotates, it will still have some attraction because it rotates like the.
I think it will have attraction and also the oscillation.
Okay, so do you change the distance between the two gears?
Yes, we have. So
the change that page.
And here is the distance for the two distance.
Yes.
Then here's the distance, and here's the here's the dipole.
So you consider it is the magnetic field will change between the distance, right? So do you got the maximum distance between the two gears, but it still works? This phenomenon still
What
works.
do you mean that?
Because I consider that when the two gears are too far, the mechanism will still will not be work. So
Yes,
you find the
because
yes.
the range of the magnetic field won't affect.
So in your graph, SCR that will be a saturation, maybe in the 0.155. So you consider it is the maximum distance, right?
What do you mean the maximum distance?
Because
the boundary.
The boundary condition that will be still.
Yes, you have boundary condition.
Okay, so could you turn to the Lagrangian page?
The equation of Lagrange.
Yes.
Here?
Yes, so could you explain more about the Lagrange? Yes, I didn't know why you use Lagrange and the meaning.
For the Lagrange equation is a way that you view the system as the energy transfer. So that this is a kinetic energy, and it will equal the I multiple the omega dot omega squared, and this is the passive one, and this is driving side kinetic energy, and this is the passive side kinetic energy.
So the V is also the energy.
And this is the potential magnetic potential energy.
Okay,
this
so
is the definition of the Lagrange equation.
So I didn't really know that. So why you use Lagrange? I mean that. So what the magnetic potential energy will be connected to the kinetic energy.
For our theory explanation, we view the systems. We solve the theory from perspective that is from the energy transfer.
Okay, so
we use the Lagrange equation.
I got it. So could you turn to page 15? So could you explain more about the theta and the R? Yes.
And here's the angle between the two magnetic dipoles.
Yes.
And so you want me to explain how to calculate the
yes. So you,
here's the if the angle will be the 2 pi divided by 3. So if this is
okay. So you always measure the same theta on the least position, right?
What do you mean the same position?
I mean because it keeps rotating.
Yes.
So you always measure the to the center and to the maybe you set it to the x-axis.
To the other ones here.
Oh, I got it. Oh, it's very clever. So could you turn to the page 19? So could you explain more about the ratio works?
You mean the convert ratio?
Yes.
And for the convert ratio, we have
okay. Time is up. So opponent, please summarize.
So I asked about the fixing process behind the phenomena. So the reporter always fix the magnet on the magnetic gear. So they because they only do the position on the gear. So they consider that is the repel force, which is a repulsion, cause this phenomena. And I also asked about the Lagrange equation. So they use this to calculate energy loss, energy transfer from the magnetic potential energy to the kinetic rotation kinetic energy. And I also asked about the ratio works, but I haven't got time to explain that. And I also asked about the kinetic energy. Yes. And for the conservation of the angular momentum, I didn't mention that. Yes. So I consider that because this will be outer torque because you just keep rotating the first gear. So I consider the angular momentum will not be always the same, always conserved because that will be outer torque.
Time's up. Thank you. Okay, so reviewer.
Sorry, could you say more louder?
I have a question for both of you. You just mentioned that you have considered the air resistance in your experiment,
yes.
right? So if there are two gears and they have the same rotational speed, and then we set it free, did you think that it will stop at the same time because of the air resistance?
What do you mean like same
rotational speed?
I think at the last moment of the phenomenon, it will have the oscillation. So it's hard to say it will have the accuracy at the same time, but maybe it will very close at the same time.
So I also consider that it would not be the same time, so because that maybe the rotation, inertia or something that would be still different, and the air resistance would also be implied by the shape. Yes.
So if still consider, and we just discussed there are two gears, and we consider the air resistance. But if you put the three gear side by side, like 1, 2, 3, yes, and I just mentioned the phenomena. What do you think? When you stop
mean
at the same time?
if I have 3 spinners, and then what will be affected?
The air resistance.
Very well. Just like I had mentioned to the point before, our theory model, including the dissipated from the air resistance, can be used to several spinners. Yes. So even if we only do 2 magnetic gears, we can.
So I also consider the air resistance would be different in the 2 gear or in 3 gears. Yes.
So we just mentioned that there are 1, 2, 3, but if today I put it in 1, 2, 3, and what is your experiment?
You mean place is triangular?
Yes.
You can use blackboard to demonstrate it. Thank you. You mean they have the same pole of direction?
Yes. You always control the center of the event as your experiment, right?
Yes, they are at the same direction. And I think that since that if the direction of this rotation will be like this one, and thus this one will be like this one, right? And since that if they have the same angular velocity and also the same strength of the magnetic field, this one will only maybe accelerate. It won't spin. Since outcome. What do you mean the outcome?
The air resistance. I was going to consider the air resistance as the outcome of this.
So you're asking, what will the air resistance be changed if we place the
well, they stop at the same time.
just similar to the last question, I think since they will have oscillation.
So I consider it would be oscillation because the two gear affect another gear and they should keep interact each other. Yes.
Okay. So reporter, please. Reviewer, please prepare your. Okay, reviewer, please start.
Just review from different property. If the spinner drop off rotating energy will be successfully transferred, if one is not moved, the energy transformation will not show obviously. I think the spinner must be pushed by driving what's to prevent it spinning several registers through changing the amount and the distribution of the magnet. That is the summary of the reporter's presentation. The theory independent magnetic field energy transformation involved. Experiment changing different shape of spinners equipped with different amounts of magnet and changing the amount of spinner using mathematics calculations to predict the purpose and ratio. the result kinetic energy decrease and turn into potential energy, which decrease and turn into kinetic energy. Repulsive force enable energy transformation, finding the theory of the ratio oscillation between two spinors. So we consider from the first stage great analysis of the statistic and detailed description about the experimental process. But it is two additional experiments for creating the spinners like 5, 4, 6, or 8. So the other question related to the topic of slides on multiple spinner is not the same as your experiment. The processor prevents by conducting the experiment as can be predicted. Well, where you put the magnet, the bundle will be the most obvious when the two magnets are close to each other. Based on the conservation of angular momentum, will the spinner get slow because of the air resistance? It will stop at the same time or not? And the recorder history will not totally stop at the same time, but I have the service question that if there is more gears like 3 or more and the resistance between them would affect the watch distance, but I didn't have the clear answer from both of them. So there must be another question I would like to extend to this experiment, because from the problem statement, the problem statement says 2 gears or more gears placed side by side, but if there are 2 gears like that, it takes experiment like 2 gears side by side. But if I put this gear into this one, so I would like to know what the experiment would affect according to the direction of the rotation, or we consider the air resistance or other situations. Okay, that's my review. Thank you.
Thank you. So, reported 2 minutes of summary.
And here are the concluding remarks. And first, this is the arrangement of the setup. And I have made sure that the position of the magnetic dipole is the same. And also, I have used the model to maintain angular velocity for the driver side. And then is the integer ratio. I have mentioned that the spinning ratio will be an integer ratio. And then the several spinners can be considered with the theory, since we have to prove that from a theory, if we place several spinners, the result of it can be fitted in theory. And the energy loss may be caused by the friction and air resistance, and we have considered the energy loss to our theory line. So our theory line has considered the viscous damping, and which will be like this. And this is used the Lagrange equation. And here's the here is the definition of converge ratio, which will be like this. And the phenomenon causes the spinners to rotate is due to the repel force, since that the direction of the magnetic dipole is the same. So that unpole and unpole will repel each other. And then I'll talk about the Lagrange, concluding for Lagrange. The reason that we use the Lagrange equation is that we view the system as an energy transfer system. So that we can use Lagrange equation to calculate our theory. And the energy we use is the kinetic energy from the passenger driving side, and we attract its angular velocity, and for the magnetic potential energy, we consider it to have a perfect magnetic dipole. We obtain the dipole moment mu by measuring the field to the Gauss meter, and so that after our Lagrange equation, we can have a calculation of the motion of the motion. And thanks, that's my concluding remarks.
Thank you. Okay, so now time for juror. Oh, because I have 2 grades, so let me start.
Oh, you start? Yeah, sure.
Start first, yeah. Then you can. So my first question is to the reviewer. Do you understand the Euler-Lagrange equation? Euler-Lagrange equation. Do you understand?
Not very clear about it.
Okay, you don't know, right? So if the reviewer don't understand Euler-Lagrange equation, my question for you is, how do you communicate efficiently to other people?
You may have to explain what is.
Right. So this is a discussion that we want everybody else to understand. So what's the reason of your choice?
To use the Lagrange equation.
Yeah.
Oh, there are different.
Short answer because we
have different ways to view the system, and we view the system as the energy transfer. So we use the Lagrange equation, since the Lagrange equation is used for the energy transfer. It's the perspective for the energy transfer.
So opponent is certainly don't agree. So what's your choice?
So I may try to use only the rotating and angular velocity instead of the Lagrange because it's very complex to understand for others.
Thank you.
Okay. I want to clarify something from the reporter. Could you turn to the page 27? 27. Oh yeah, yeah. So the kinetic energy, the blue line,
yes,
is calculated like based on the calculation, right?
Yes.
So you measurement.
This is I think here is the measurements.
Measurement.
Yes.
And how about the potential energy? Also measurement.
The potential energy. You mean the line of the potential energy?
Yeah.
This is still the measurement.
Measurement.
Yes.
Based on the distance between different t's, and you sum over the all pairing,
yes.
right?
Yes.
Okay. And have you tried to sum all the two terms? Yeah. To see whether it's conserved. Yeah.
You mean what to have a line that shows the total energy?
Yeah.
We believe that if we sum it together, we have a energy like this, and we will have total energy line like this, and it will be the sum of the potential and the.
But you didn't really do it.
And we
just think it's that way. Yeah.
But it will be easier to do it.
Okay. The second question, a quick question is that there's a frequency, right? Either from the kinetic energy or from potential. So is that a matter? I mean, that relevant to some parameter?
Since that, and when the phenomenon is occurring, there will be repel force and maybe oscillation, so that there will not be a line without any amplitude.
So I'm saying the very large frequency. Yeah.
The frequency here.
Yeah.
Which I just like I mentioned, which is because the forces, because it may be a complicated forces acting with interact with each other. So it will have some line like this.
Okay.
Chaotic means it's a dynamics is very sensitive to initial condition. So can you prove more rigorously this is indeed a chaotic phenomenon?
You mean the base for this one? For the last one, you want me to have the evidence to show.
It looks like chaotic, but is it really extremely sensitive to this initial condition?
For the explanation or for the chaotic oscillation, since that their angular velocity is very small, and since it's still the repel force, so it will only oscillate, and this is we call the chaotic oscillation.
Do you agree this is really a chaotic phenomenon?
So I consider that maybe a reporter can analyze the magnetic force between the attraction and the repulsion. So if you know that would be maybe chaotic. Because I didn't really know that definition of like chaotic in the reporter's slide.
I agree with the I think reporter should think about the current. I think that is not consider all the parameters or other situations. I agree with the opponent.
Any more questions? Okay, so now the scoring time. Okay, so now the score for the reporter is 8, 8, 7, 8, 7. the score for the opponent is 9, 8, 8, 7, 7. The score for the reviewer is 6, 5, 6, 5, 6. Okay, so because this is the last fight, any viewer want to make additional comments?
Okay, I just like to encourage all of you, to continue your career with physics. Best students, in this city. Congratulations, no matter what.
Okay, thank you very much for your effort and participation, and hope you have a nice dinner. Okay.